about performing QA/QC and range from applying new applications to tried and true, use the old-fashioned techniques, and also looking at integrity of the data, throughout the data lifecycle. And so we're very, very honored to have these speakers with us today. First up, I'm going to get his bio here. Jonah Waterman, who comes to us by way of Newfoundland, which is very exciting. This weather's nothing for you, is it? No, okay. It's summertime. Jonah came down from Newfoundland and attended Appalachian State University, where he got his BS in geography with a concentration in GIS science. He is now the associate. He's the primary role as the GIS technician for Greenville Utilities. He is doing QA/QC analysis. He does digitization of as-built designs, creating web maps through FlexViewer, georeferencing, and he provides many services, including mapping, publishing, and topological analysis. Coming from Nova Scotia and enjoying North Carolina, he does a lot of camping, hiking, canoeing, traveling, riding his motorcycle, and spending time with friends and family. So with that, I introduce Jonah Waterman.
First of all, thank you everyone for coming on out. I thought it was just going to be a bunch of tumbleweeds and crickets out there today, so thank you for battling the elements to come see this presentation. I want to talk to you a little bit about providing quality assurance and quality control measures within an enterprise GIS utilizing Data Reviewer. Oh, also my co-presenter could not make it today, so I'll be filling in the gaps, so it might get a little dicey at some parts. And I can't move my screen now.
This new system is really very bizarre. We've got technical people here. And
Y2K 15 years later. There we go. Sorry for that. The background. There's been a natural transition from analog data to digital data. GIS is now transformed into more of a modeling environment. There's a paradigm shift. We're not making just pretty maps anymore. There's a high demand for high spatial geodata. As you can see from the images above, we're not making just a pretty map. We're starting to get into the weeds and really see that we're creating data, but are we creating?
if you can.
But are we creating good data? So, some of the challenges that we face is outdated legacy rules, identifying end uses, and quickly analyzing problems, projecting the scope and associated cost. Greenville Utilities, like many other organizations, is in a paradigm shift. We're transitioning from, we're transitioning from not making it just a pretty map anymore, but we're transferring into more of a digital realm. We're implementing new systems such as Responder. It's an outage management system that tracks electrical outages and efficiently dispatches crews to those locations. Like I said, outage management is an incident management system, and it's based upon the connectivity within inside a geometric network. It heavily relies on edges and junctions that must be properly snapped together without any gaps, so flow can actually trace through the network. Simplistically, this is how the responder operates. A caller calls into Greenville Utilities to report an outage. Well, that caller is then geocoded into Responder to represent the XY location. If multiple callers call into Greenville Utilities, Responder has the intelligence to identify whether that outage is an isolated incident or a multiple incident with a common outage source. So if your network is not properly snapped together, then you can't trace flow throughout that network, thus increasing our response time and decreasing our customer satisfaction. This is one of the main reasons we began to look into data quality solutions to manage our data. We found out that Data Reviewer could actually provide us with the answers we were looking for, such as what is the current health of our GIS, how many violations are occurring in our network, where are those violations occurring spatially, how long until we clean those problems up, and moving forward, how can we prevent those errors from occurring in our network. So this caption really highlights a lot of our data quality issues that we deal with on a daily basis. It's a vicious cycle. Whether we receive bad data or in the loading process implement bad data, or we create bad data, or within the final review process we implement bad data. We all know the various ways to implement or create bad data, but how do we prevent these data from occurring, or these errors from occurring? I think first we need to step back and look at what is data quality. Data quality is based upon multiple components, whether it's your spatial accuracy, your XY location, the completeness of your data. Are you missing features in your data set or your feature class? Or the temporal quality, for instance. You wouldn't want to necessarily digitize land use change based off of 1960 aerial photography when you got the latest and greatest 2015 aerial photography. Data quality is really driven by the business needs of your organization, and it's dependent on those processes. And it's also directly derived from clearly defined QA/QC procedures. This is key to data quality. You have to have documentation that really clarifies what your mission, what your goals are. What are you looking to obtain from your data? So really achieving a healthy GIS is really using the right tools for the right job. It has to be simple. Well, Data Reviewer is one of the simplest, easy to use software tools out there. If you have an enterprise license, it's free. You can use it. It's very simple. I figured it out, so it's pretty simple. It's automated. You can run Data Reviewer on an ad hoc request against a polygon. You can run it against a feature class, your database. There's numerous quality control checks that are available. You can choose from over 40 checks, whether it's table checks or geometry checks. There's all kinds of different checks out there, domain checks, subtype checks. There's something for everybody. And you have the ability to interact, store, and manage your results. So you can basically query your data, find those violations that are occurring in your network, and basically share that information with your colleagues, your coworkers. You can manage those results in tables. It really increases your transparency in your operations. So really, achieving a healthy GIS is accomplished by using the right tools within a GIS data quality control framework. Let me explain what this framework is. Well, this is the framework used in my organization. We first started at the top with the service catalog. What we did, we basically listed all of the job functions, all of our tasks that we do on a daily basis. We document all those processes, and we create a catalog. Once you have that catalog in place, you can implement a job tracking system. That job tracking system really is basically just for logistics. It manages your tasks and increases your transparency so others in your organization can really see what you're doing on a daily basis, which increases their confidence in your abilities. Then it goes to the matrix. Now the matrix was a really helpful tool that we utilized, and I want to explain a little bit about this. So this is basically the matrix. I'm not talking about Keanu Reeves and the matrix or anything like that. I'm talking about taking all of your feature classes, and what you do, you have an X and Y axis, and you basically list all your feature classes across the top, along the side. And what you do, you basically, this is set up to understand the spatial relationships that exist with your data. So as you can see, I'm using a water example. So our feature classes that I have posted up here is a tap, service line, and a main. And same feature classes on the side. All you basically do is come in here and whatever feature touches the other feature, place an X there. This is a great way to document the spatial relationships that exist within your network. And it's really a good stepping stone before you start running your data reviewer checks, because once you understand the spatial relationships that exist, you can basically take that Excel spreadsheet and go into data and look at the Excel spreadsheet, go into data reviewer and start implementing those checks within data reviewer. So from the matrix, we start our testing in our data reviewer checks. After you start testing all your various checks, it's a great idea to start documenting these checks in it's a business catalog. So these are all of your engineering rules, your business rules implemented into a catalog. So it's all documented. This helps because it's great for training purposes to hand to a coworker and say, here, this is how this procedure is handled. It increases your transparency at your organization. And once you get all this done, that's when you can start implementing your batch processes. Now I want to talk a little bit more about data reviewer. So with data reviewer, you take these checks, you run them into data reviewer, run them against your feature class database, and you get two outputs. You get GIS rule violations, highlighted in the red here, and these are going to be your point line and polygons, where all your violations occur in your network. When you identify these violations, you can basically export these as a feature class shapefile, send these to a coworker, have them clean that data up. Or the second output, I think is the best output from data reviewer is the standardized reporting, because this gives you a standardized method to just run those reports on a weekly, monthly, yearly, whenever you want to run these reports. You can set those batch jobs up to run those reports, and then this is powerful up to upper management. You can give this to your boss and say, this is the current state of our GIS, this is the health, this is where we need to allocate resources, this job is more important than this job, and so forth. So you can really start to prioritize your jobs. So this is really a great tool. I'm going to switch gears real quick, so just bear with me. There we go. Okay, so I'm going to give you guys a little demo about Data Reviewer and how simple this is. And my co-presenter was supposed to do this part, and she could not make it, so I put this together this morning. So that's how easy it is to generate these batches, run these rules, and generate some output. So let me kind of guide you through some of these processes here. Okay, so what you're looking at here is a MXV, of course, of a gas network. So you're seeing a gas network with service points, valves, T's, all the kits and caboodles. And so what we're going to do, this is the actual data reviewer toolbar right here. You go up here, customize toolbars, and it should be available in here. So this is the toolbar that I use, and it's really helpful. So basically, it's kind of like just starting an edit session. You come in here, you create a session, and you set it up, and you connect to a database that you're trying to test. You create a session. Let's say we want a new session. We're going to start up session 4. We're going to start that session. I like to turn that check off. We're going to apply that and close. So what you can do after you have your matrix set up and you want to test some rules against your database. Well, there's over 40 checks available that you can test against your database. And you can run individually, or like I said, you can run against huge batch jobs. So here are some of the available checks. You can look at duplicate geometry features. You can look at feature-on-feature checks, polygon checks. You can look at table checks. So, for instance, a table check, we utilize this a lot. How many null values do we have for apprentice IDs, or size of a water main, or size of a gas valve, et cetera, et cetera. You can run topology checks, and there's also some advanced checks you can use. And I'm just going to run a check real quick, just show you how easy this is. So we're going to say a gas valve and a main. And what I'm going to set up and say is that valve size and main size must be the same. Okay? So we select our two feature classes. The spatial relationship check we want to select is intersect. And then we're going to compare these features. And this is great because you can actually compare two separate attribute table values. So let me find diameter. So I'm basically saying valve diameter is not equal in the operator to let me add that, select OK. We can come down here and put in the remarks, fixed size, so a technician can see this remark. We can set a severity. This is a 1 or this is a high value. We're going to say it's a high value. We're going to select OK. And now what we're going to do, we're going to say, let's run that check. And we can either select the current extent, a definition query. So you could basically have a polygon, like maybe you have polygons for different work orders. You can definition query against a certain job, a certain coworker. I could basically run all of Chris's work and say, let me see all the mistakes Chris made in the last month. Or you can run against the full database. So we'll just pick the full database, and hopefully it doesn't take too long. And I found one problem. It's because I made it earlier. Okay. So we're going to say OK. And we're going to zoom to that error. And what it's done is it's actually selected that violation occurring in our network. And we can validate that right now. We can actually select the main. And the main says it is a 2-inch, okay? And the valve is a 6-inch. So just like that, within 5 minutes, we ran a check against our database, an individual check, to look at different valve diameters, and came up with a problem, or came up with the violations. So now I can export that violation to a coworker. I can save it. But I'm moving forward. I'm going to change gears a little bit. So I think one of the best things is really running a batch job. So we started our batch, close it out, or we started our session, sorry. So I'm going to add, I've already created a batch file this morning, okay? So I'm going to say NCGIS batch, okay? So I have two rules, and I just tested one of those rules in front of you, which is valve diameter must match main diameter. But what I'm also going to do is a T must be placed at the intersection of 3 mains. And that's not what that's supposed to be. Let me switch gears, I'm sorry. I'm going to save that file somewhere else. But what I can do is I can also run this batch And you can validate it, say no errors found, say, okay, we're going to clear out this other violation, and we're going to run this batch. And this batch is basically service points must have a premise ID. And this is very valuable for, um, CIS systems and customer service so they can link an account number to a person that's getting utilities. Menu records. All right, I'm going to back up a minute, guys. I'm sorry. Okay, so I've just made some changes. I've just removed those premise IDs. I'm going to save my edits, stop editing, reload my toolbar. So I just found 22 records in my batch job, okay? So now what I can do, I have a table. This is all a table of the results. So I can basically come in here and I can either pan through any of these results. So I can zoom to, and really interact with a lot of these errors. I can also generate a report right on the fly. Okay, that's simple. Put it in my desktop, service points, generating an Excel report, and here's your standardized report. That instant access to reports. I can basically email this to a coworker, to my boss, say this is the current health of this batch job that I just ran against our GIS system. All right, I know I'm running out of time, so let me move forward. So what you can also do, once you set these batch jobs up, you can really automate these batch jobs. So I've created a model, and these models are really helpful because you can basically create a model, a data reviewer model. You can export that to a Python file. You can run that on Windows Scheduler, or you can run it on ArcGIS Server, and you can run it on a daily basis. You can run it on a nightly, weekly, monthly, whenever you really want. It's super simple. It's just two tools, link them together. You basically create a session over here, name your session, and then you execute your batch file job. Right? You run that model, so you can run it. You can actually export it to a Python file, place it right up under Windows Scheduler or ArcGIS Server. We can actually run this model right now. It's only going to take a second. All right. Okay, so the model's completed. We're going to go over here to our session manager and retrieve that batch that was that model that was just completed. So you can see I'm on session 4 right now that I just created that the previous batch under. So you can see service session 5. It basically created a new session labeled session 5 called service points without a premise. I can start that session. I can apply that session. Okay. I can open that session, and here are all the rules. I can hit this symbolize reviewer records, and this can actually activate, so you can see actually right here are 2 service points highlighted in red that have no premise ID. So this is very valuable for CIS customer information to, these numbers need to be out there so we can actually bill those customers. Okay, so really what I wanted to show you, it's super simple to create an individual check, to create a batch job, to automate that, putting that that batch file in a model. You can export that model to a Python file, place it on our GIS server. So I'm going to kind of wrap it up because we have 5 minutes left. That's pretty much the gist of it, and it's really simplified to go ahead and okay, so kind of rounding or ending all of this. So basically, the road ahead for your organization. You want to identify the key players. You want to identify the stakeholders that are really designing the business rules, or if you work in a utility company, the engineering rules that govern or guide your GIS data. You want to define what data quality is for your organization. You want to identify which components of data quality you're interested in preserving, and develop a GIS framework. We can give you a fancy tool, you can have data reviewer, but without a framework in place, you're only going to be so successful. And share your results with your organization. It's going to make you look really cool and great if you give your boss a report and say, here's the health of our GIS. This is where we need to allocate resources to clean up. It's super simple, easy to use tool, and it don't work for Esri. I just like the product of data reviewer. And there's also a huge network of data reviewer community out there. So you can, there's all kinds of ESRI training available. There's seminars, and there's a great forum on GeoNet. And you can really link up with some people that have a lot of knowledge with data reviewer. I post up there a lot, so you can see some of the questions I've been asked and answered and whatnot. So anyway, I'm going to leave this couple of minutes for some questions if anybody's got any. Well, we have at Greenville Utilities, we have 4 utilities. So we do electric, water, sewer, and gas. So I've created a framework to govern over those 4 databases. So I look at anything from attribute tables, queries. We've just begun to implement work and asset management, WAM, and that heavily relies on attribute information. So we can basically, figure out the cost for that asset. So, and then I've created geometry rules and really because Responder heavily relies on the connectivity within our system. So if we have any gaps in our system, that's going to hinder our response time, increase our response time, and decrease our customer satisfaction. Well, we're slowly updating our client records. The ones that are incorrect, at least I can basically pinpoint which, premise IDs, for example, which service points do not have a premise ID. I can give that to an engineer. They can identify, this is this premise ID for this location, and we can start cleaning up this data. So, well, as long as you have that unique ID linking back, you can, sky's the limit. So, oh yeah. Anybody else? I wasn't on time enough. Don't be shy. Go ahead. It's really, we deal with our group. We have a GIS data services group, which is about 6 people. So we share a lot of these violations back and forth. And we work directly with the engineers and basically prioritize what's the most important jobs for you to fix right now. And connectivity is the big one for the electric department. So, but yeah, there's a lot of a lot of collaboration with the engineers. So, but we also provide the reports to upper management. They see that stuff. So. Well, I'm going to throw the big "it depends" up there because it all depends on the situation.
Okay, but that has
You
to
know,
address
some of the
what
errors
it
we
is.
can
It's video,
identify,
it's
okay, we can fix this.
Oh,
If
you
it's
already
more of
done
a
it?
complex
Okay.
situation where we don't know that actual pipe size, we actually had to get in contact with the engineers. We may have to get in contact with the field operators and go out
Well,
there
you
and
want to stop
identify
this,
those
record
violations,
it,
bring that
and save it.
information back
You
to
got the
us,
little cheat sheet that
and
tells you what to do.
we can update that system. However, there is this
It's up to
can
you
be
guys. I
all
think the
linked and
idea is to
automated.
go
You
back
can have an
to the website
iPad
and look at specific
and
sections
basically
and look at
any
orders.
mobile device and have this on, have the reviewer on it. So basically, your guys out in the field can basically identify where these violations are occurring and directly send that back to a GIS technician, and that technician can open up that table, pan to that table, change the status on that record, say, okay, I fixed this record, this was the outcome of that record. So there's a lot of table management. It's a great QA/QC platform. So it all depends. Right. It tags your name, your username, so we can query through the table. You can go to the tables, you can query the tables and say, okay, what was all the jobs Chris sent me, or what did Robin send me last month on this one particular job? So you can really query the tables, pan to different areas. There's a lot of interaction.